We're here in the Loring booth. Loring is a manufacturer of roasters, very specialized, and part of the issues we have in specialty coffee is that as roasters move closer and closer and closer to their customer bases and metropolitan areas, there's an increasing impact on the communities on using fossil fuels and emissions and the smell of roasting. And Loring has come up with technology that will mitigate some, or if not all of that. And I'm here with Ron Kleist.
Good morning.
Of Loring, and he's going to explain some of that to us. Tell us how you solve some of these problems for the specialty coffee industry.
Well, first, I didn't solve the problems. They were solved by an inventor named Mark Loring Ludwig. The middle name became the company's name. And Mark was a guy who was involved with a very big company called Heat and Control. And while he was involved with Heat and Control, he learned a lot about heating systems and control systems. After several years of traveling the world, solving problems for them, he decided, I don't want to travel anymore, I'm going to stay closer to home. So he started up his own tea bagging business. And as he was doing tea, he realized this is a tough competitive market and I'm not making much money. I'm going to buy a coffee roaster, roast coffee, grind it and put it in tea bags. And that's how he segued into the coffee business.
Great.
He did that for a few years and he became very frustrated with the roaster that he was using. It was a conventional air roaster, and it wasted a lot of energy and it put up a lot of smoke. He thought, I think I know a way to solve this problem. So he did something nobody had ever thought of. He looked at the 5 basic pieces of a roaster. You have a roasting chamber, a cooling chamber, a cyclone to remove particulates from the air. You've got a burner to create the heat, and you've got a control system. So Mark looked at those things and he was thinking, well, outside of the box, how do you make those 5 things do the magic of removing the smoke, heating up the coffee, and producing something that's better? And so his invention was on a napkin, like a lot of inventors do it, on a napkin at the Acapulco restaurant in Santa Rosa, California, where he drew out a picture of a cyclone. He said, if I put a burner in a cyclone, I could do something really unusual. There are people who've put burners around cyclones, but nobody ever tried to put one inside. So when Mark did that, it made a profound change in the way coffee gets roasted. Miles, the way this works is we bring in an air gas mixture under pressure into a burner that's inside of this cyclone. When that burner ignites, it creates a very hot air stream. The magic of putting it in the cyclone is when the cyclone is spinning, the heavier elements go to the outside, chaff, or cooler air, and the hotter elements, the lighter elements, which is hot air, go straight up the middle. So what Mark was able to do is put an incineration tube down inside of this cyclone with a burner right underneath it. He separates the heat into 2 zones. There's an incineration zone down here where the air is far too hot to roast coffee. But up in here, you have air that's at the right temperature for roasting coffee. So what Mark did is he took the air out of the top of this cyclone, brings it in to the roasting chamber, where it roasts the coffee and then it returns into the cyclone to be recirculated. People have tried recirculation schemes many times, typically with very bad results because you've got smoke in there that destroys the flavor of coffee. What we're hearing from our customers is we have the exact opposite effect. Coffees come out of our roaster tasting very clean, they're very bright, they have great high notes, and at the same time they have good body. The reason we believe that happens is several factors. One is a cyclone not only separates chaff, it separates smoke. So during the recirculation process, we're continually removing smoke as well as chaff from the system. The only air coming in comes in through that burner. Because it's coming in through the burner, there's no oxygen. It's what's called a stoichiometric flame. So we remove virtually 100% of the oxygen. So we think that the gentle heating of an air-style roaster, plus the fact that there's no oxygen, plus the fact that there's higher humidity, because when you burn gas, you get water, vapor. So we have a higher level of humidity, almost no oxygen. Those 2 things we believe affect the flavor of the coffee. The reason I say we believe that's the case is we haven't actually run all the tests that we need to run, hooking it up with Draeger's tubes and things like that to try and get precise measurements. But the important thing to us was, what does it do to the coffee? And if you ask the people with the great palates, people like George Howell, Kentaro Maruyama, the roast masters at Solberg and Hansen in Oslo, Norway, these are guys that spend a ton of money every year buying COE coffee, and they're not going to roast it if they can't get a great result out of it. So they're buying our product because they say the flavor of the coffee is spectacular. There are several other benefits that come out of a system like this. If you talk to George Howell, who is in New England, you've got winter, spring, summer, fall, and sometimes you get all four of those in one day. Air pressure changes, the humidity in the air changes, the temperature of the ambient air changes. It makes no difference inside of a Loring. It's always the same in here because everything's coming in through that burner.
And it determines the atmospheric pressure inside the system.
Correct, correct. So it's always more than 1 atmosphere inside that roast chamber. If you compare us, for example, to a conventional drum roaster that has no afterburner to get rid of the smoke and odor, we're going to be maybe 15% more efficient in our use of energy. But as soon as you put an afterburner on a system to get rid of the smoke, you're consuming up to 4 times as much fuel in the afterburner.
Yes.
So when you look at a Loring, you don't have to imagine a giant afterburner sitting on top. It's unnecessary in this system. In fact, you could vent right from the top of the cyclone into the air. You don't need anything up there because no smoke, no smell comes out of there. And how do you cool the beans? It's commonly believed that you need to take the beans from the roast temperature to below 40 degrees centigrade, which is 104 Fahrenheit, in 90 seconds or less. And that prevents the baking of the beans. And the way Mark did that is he came up with the idea that you want to have a much smaller cooling chamber. Instead of one that's spread out and has very low velocity air, he brought the chamber in close and then draws a very high velocity of air through it. So we achieved that magic of getting these beans down below 40 degrees centigrade in 90 seconds or less.
By simply increasing the air pressure and shrinking the size of the cooling
Right,
drum?
right. The conventional idea was spread them out and stir them and let air come through there. But when you tighten it up, you get much higher velocity. And if you stir it properly with counter stirring measures, you can get this thing to cool as faster than the best systems that are out there today. In order to make this the most productive machine you can buy at this size, we have things like a vacuum loader to get the beans up quickly. The computer controls when the gate opens and the beans drop in. In this particular model, it's a manual door to open and close to discharge the beans. But otherwise, it's an automated system. So a roast master, in a sense, he trains this machine when he first gets it. He puts in his favorite beans and roasts until he gets the profiles that he wants. Every time he's roasting, it's capturing 160 data points, and it downloads that through the internet to his laptop. So at the end of the roast, he's got a complete profile of what that roast was. He can enter in notes right on the screen. He can go cup the coffee and make decisions later. Hey, you know what? For some reason, I made this change, and wow, the results are spectacular. And now you've got a paper trail to go back and repeat that.
That's a terrific system.
Thank you.